Hi, today I'm going to show you a demo on safety applications in our one of our IP core, SupersoniK. So SupersoniK is for high performance computing application. It has a 64 POSIT cores, and then it can do a lot of high order translation functions, square root, inner square root, logarithmic function, and so forth. So today in that IP core, I'm going to show you the CFD application. As you know that CFD applications are required in a lot of fluid dynamics, vehicular dynamics, or turbulence effects, or many applications. So we used OpenFOAM. It's open source. So in order to build in order to run this OpenFOAM on our IP core, what we did was that we downloaded from I'm going to show you. We downloaded from open source installation from source, OpenFOAM installation from source. So if you type OpenFOAM installation from source in a search engine, you'll get this link. And then they have given how to download those instructions. So you have to you have to download this tz file, gzip files, and then there is a build guide here. So this build guide, you click on the latest guide, so then it will direct you to this one. So in this link they have mentioned how to build from a source. So what we did was that we had taken that source and source codes, then we tweaked certain part of the source code wherever it is compute intensive applications. What we did was wherever the compute intensive, we have directed those execution tasks to SupersoniK, and then we built from there. So, and today in the AWS demo, I'm going to show you some regression test on that part. Okay, so yeah, now I'm assuming that you have I would say you have our FPG image and programming features, settings, and so forth in AWS. So I'm going to show you a demo on that part. So those who are not familiar with AWS, just I'm going to give a little bit overview of that. So in order to run our IP core, you need to register in or create account in AWS, and then once you create it, go to AWS Marketplace, and then select FPGA Developer AMI, and then you configure for F12X large. And then you have to select how much memory, or what are the IP protocol you have to follow, and so forth. Once you do that, instance will launch, and then you have to give a key pair. That key pair you can create during the instance launch, and then you can connect to SSH or Putty. So in this example, I'm going to show a demo on Putty. Okay, so now we are connected to Putty, assuming that you have loaded our FPGA image. So in order to run OpenFOAM, so you just have to enter make openfm test, and then click enter the command. So it will it will go through the lot of regression tests. So solvers, smooth solver, many cases. So as you've seen that it is passing the test. So around 282 iterations. Yeah, and it tracks around 10, and then seed particles, 10 seed, 10 particles, and so forth. So as I mentioned that we have tweaked certain part of the code wherever it is compute intensive applications. And then so wherever it is doing a lot of arithmetic computation, it is doing in native POSIT arithmetic format. So yeah, so that's it. If you have any questions, please do get back to me via email, or drop us a comment in our channel. Thank you.